If you consider any of the system as a Rdbms, first it must have a ability to have this relational capabilities. Each unique piece of data, that is atomic value, should be able or it must be accessible with the help of table name, and I have to have a primary key as well as the attribute. If I wanted to access the data, I have to use one powerful programming language. So as of now we have a SQL. Hello everybody, a warm welcome to one and all. Welcome to the first session of Chapter 1 and we are in the Unit 3. So the Chapter 1 name is Advantages of Rdbms and we are dealing with the B.C.A's 4th semester subject called Database Management System. In short, it is Dbms. I am Rohini T.S., Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So in the previous session, we got to know regarding the Unit 1 as well as we have learned the topics regarding the Unit 2. So in our today's session, we'll start with a Unit 3. So that is regarding, it consists of two chapters. One is SQL and first chapter is regarding advantages of Rdbms. So in our today's session, we'll see about the first chapter, that is advantages of Rdbms. So these advantages of Rdbms will going to be specified with the help of this Court's rule. So in the previous session or even in the previous chapter, we got to know regarding what do you mean by relational data model, what do you mean by constraint, what is an entity, what is an attribute, everything we got to know, right? So, and also at the last session, we have learned regarding the normalization. So why the removal of that redundancy or a duplicacy is important in the database, that we already got to know, right? So in mainly to maintain the integrity of a data, mainly to have a consistent data in the database, we had all those concepts. And also based on this Scott's rule, so he was a scientist, he was a computer scientist, so that person has invented some of the rules in order to improve the efficiency of a relational data model or a relational database management system. So if you are managing the database in terms of relation or in the terms of tables, then we are going to call that as a relational database management system. That is also software which is managing the database in the terms of relation. Everything will be in the terms of tables that consist of rows as well as the column. So now we'll see, we have 12 rules here. So that 12 rules will going to help us in order to improve the efficiency of that Rdbms. So if we followed all those 12 rules or if we got to know regarding all those 12 rules, then it will be helpful for us in order to improve the efficiency of a relational database. So that is what the today's topic. So we'll see the first rule. Before that, we'll see who is this Scott and what he has invented, and this Scott's rule is based on what methodology? You can see here, E.F. Scott was a computer scientist who invented relational model. So what he invented? He invented relational model for the database management. So we have a database, that management of that database is important. And also, we have this relational model. So we got to know what is relational model, what are its advantages and how it will going to be used, and what do you mean by entity, relationship, attributes and types of attributes. Somehow we know everything regarding this relational model. So in order to implement or to invent this relational model for the purpose of database management system, E.F. Scott will going to play a very important role in that. So he has invented some of the 12 rules or a rule 12. Up to that, he has given advantages at each rule. So if we follow that, it will be helpful in order to improve the efficiency of accessing the content which is there in the database, that too in the terms of relation or a table. And also based on the relational model, we have a relational database that was created. So if it is a relation, then only you have to think that, then only you have to remember it's all regarding table. If it is a table, then it consists of rows as well as the column. If it is a table, then it consists of rows as well as the column. So then rows are nothing but tuples and columns are nothing but attributes. And also we know the 3 schema architecture, right? So in that we have 3 levels: logical level, conceptual level, and also we have a external level. How 3 levels was invented, how 3 levels are interrelated to each other. By knowing all those things, we are maintaining the database management, or we are having the maintenance with respect to the database, that too in the terms of relation. So now we'll see the rule 0 up to rule 12. So that here we have a rule 0. What it states then? Rule 0 states that for a system to qualify as an Rdbms, if I wanted to consider any of the database management system as a Rdbms, then it must be able to manage the database entirely through the relational capabilities. So if I wanted to consider anything or any of the data as a system as a Rdbms, then first rule or 0th rule says that it must be able to manage all those data in the terms of relational capabilities. So it must have a relation with one table to another table, and how one attribute is affected on another attribute, how it is going to be decomposed. So all those relational capabilities has to be there. It has to follow the 0th rule. So that if you consider any of the system as a Rdbms, first it must have a ability to have this relational capabilities. This is regarding rule 0. So now we'll see about the rule 1, that is information rule. What about this information rule? If it is an information, then we are getting some knowledge out of that. So what this rule 1 states that all the information, even metadata, that is data about another data, we can call that as a data dictionary also. So that it is to be represented as stored data in the cells of table. You understood? That is what all the information, whatever we have in the database. So first, if I wanted to consider any system as a Rdbms, it has to follow the relational capability. So it has to be in the form of table. So in the first rule or a rule 1, all the information has to be stored in the cells of a table. First, we are going to create a table, that is, it must be able to showcase the system in the terms of relational capabilities. In the rule 1, we are going to include all the data, even metadata, that has to be stored in the cells of a table, so that the rows and columns have to be strictly unordered. So for example, there should not be order, like for example, it should not be like 2 cross 2, 3 cross 3. It should not be ordered. So I can have 2 attributes and I can have n number of rows. I can have only 5 attributes. I can have 500 rows. There should be no order, or there should be no strict order for the rows and columns, whatever we have in the relational database. That is regarding rule 1. And rule 2 is guaranteed access. I have created a table and I have put, or I have dumped some of the content in the table. If it is not allowing me for the access, then what is the use of doing that? So access or guaranteed access is required in the rule 2. So this states that each unique piece of data, that is atomic value, should be able, or it must be accessible with the help of table name, and I have to have a primary key as well as the attribute. So if I wanted to access this content, you just imagine I wanted to access the content which is present in this cell, that is related to certain row and certain column, and it has some table name. So I can access this content with the help of name of a table as well as a row and as well as a column. By having all these rows, column as well as a name of a table, I must be able to access the content whatever is there in the table or a relation, that is accessed or a guaranteed access as per the rule of rule 2. So now we'll see the rule 3, that is systematic treatment of null. If I say null, then there is several synonyms in the database. So that null will going to have several meanings. So it can be related to missing data. Even missing data is also considered as a null, and even not applicable data is also considered as a null, and even no value for that. So if the value is not available, it has some value, but at that time it is not available, then that is also what? Not applicable, and even no value. So we have several meaning for the null, but if I wanted to consider a null in my database, I have to follow the same meaning from one table throughout my database. For example, I have a student database, right? So in that I am going to have n number of tables, and among that tables there will be a chances of having null values. So if I consider that null as a missing data, if I am giving the name of a null as a missing data throughout my database, the null, wherever I am going to mention null in any of the relation, it must be missing data only. So in one relation it should not be like missing data, in another relation it should not be like no value, and in another relation it should not be like not applicable value. So it should not be like that. If I consider null as a no applicable data, then throughout my database it has to be same. So that is what systematic treatment of null. So then there will be no chances of having an inconsistent data. For example, if I am not getting that data, or if that data is missing, if I am considering that data as a missing data, then I can apply the value as a null. If it is consist of no values, at the time I should not consider that as a null. So whatever the meaning that we are going to give for a null in the terms of missing data or not applicable or no value, it has to be retained same name throughout the database. That is what you have to remember. It should be handled consistently, so that you should not treat the null in a different manner. So that primary key must not be null. So you know about the rules regarding this primary key already, right? If I am making any of the column as a primary key, it should not be null, and it must be unique in nature. It should not have the duplicate data. So in order to have that, so there you should not include this null, and expression on null must be give null. So if the values is null, then the resultant must also be null. So these are the things you have to remember when it comes to the rule 3, that is regarding systematic treatment of null. We'll see about the rule 4, that is active online catalog. Already we know about the catalog, right? That is what metadata. It's a data about data. For example, it's like a index in your textbook. So though that index sheet is a data itself, but if I see the data, I can get the data, or else I can get the access to another data. We are going to call that as a catalog. So that this rule states that the structured description of a whole database must be stored in online catalog, so that it will be available to everybody in order to understand what is the description of a database, or what is the description of a complete database, what it comprises of, how many tables we have, what are the constraints we have in each table, how many columns we have. So if I get to know, then it will be easy for me to give the content, or it will be easy for me to give the type of value they are seeking for. So that is also will going to improve the consistency in the database. So that in the active online catalog rule states that the structure or a description of that database has to be stored in the online catalog, so that the data dictionary which can be accessed by the authorized user. So it should not allow everybody to access. If you are an authorized user, if you are a genuine user, you belongs to that database, if you wanted to access that content, then only it must allow you to access the content. Only if you are authorized access, then there must be a chances of having or accessing the content. Otherwise, there will be no confidentiality. So we have to provide security as well as it has to provide the accessibility to the authorized users. So that data has to be there in the online catalog wherever you want and whenever you want, at what time you want, without any constraint you can access the data, so that you can get to know what is the structure or a description of a database. Then it will be easy for the user in order to access the content. So that is regarding rule 4. We'll see the rule 5, that is powerful language. So as we all know that if I wanted to communicate with you, then I have to talk to in a language that you can understand. So if I'm talking language that you can't understand, so then there will be no communication between us, right? So in the same way, if I wanted to communicate with a database, if I wanted to fetch the content from the database, then there must be some powerful programming language. So some powerful query language has to be there. So as of now, we are considering SQL as a query language language or powerful query language in order to talk to our database. So with the help of that SQL language, we are accessing the content from the database. We are talking to that, we are interacting with each other. So that has to be there if I wanted to consider any data or any of the database management as a relational database management. So that one well-defined language must be there to provide all the manners of access to the data. So that if I wanted to access the data, I have to use one powerful programming language. So as of now, we have a SQL. So that if a file supporting a table can be accessed by any manner except SQL interface, then it is a violation to this rule. So that if you wish to access the content of database, then we have to use programming language. We have to use a query language, that is structured query language called SQL. So this is regarding rule 5. Let me go to the rule 6, that is view updation rule. What this rule 6 says, all the view that is theoretically updatable should be updatable by the system. For example, if I have a table, I am writing a table manually. So if I am doing some of the updation in any of the table, if it is possible theoretically, that means if I am doing that theoretically, then it must be able to do the same thing, or it must be get updated even by the system. So if it is possible theoretically, then it has to be updated practically also. That is regarding 6th rule or a view updation rule. So this is regarding rule 6. Let me move to the rule 7, relational level operation. Operation includes what? There could be a retrieval, updation, creation, insertion, deletion. If we have a database, if I am putting all the contents into that database, then it has to follow some of the operation. It has to perform some of the operation. If it is not performing the operation, if it is not allowing us to access the content, whatever we have, then whatever we are doing till now was the waste thing, right? So there must be insert, delete and update operation at each level of relations. So at each level of table or at each level of relation, it must be able to have this insertion operation, deletion as well as update. Basic, all the fundamental operation has to be there in all the levels of relation, so that even set operations are also has to support from the relational database management system. So this is regarding rule 7, that is relational level operation. It has to allow us to perform all these operations at each level of relations. We'll see the rule 8, that is physical data independence. If I say this physical data independence, you have to get back to your unit 1. Already we have learned regarding logical data independence as well as physical data independence, right? So we have 3 levels in the 3 schema architecture. First is physical level, conceptual level, and also we have a external level. So then what this rule 8 says that, we'll see now first, the physical storage of a data should not matter to the system. It should not affect the application. So whatever the changes we are making, whatever the content we are altering, if we are altering the order of a records, whatever the changes we are doing in the physical level, that should not affect on the external level or to the user who is using that application. That application level or an external level should not get changed or should not get affected if you are doing some of the changes in the physical level. That is what physical data independence. If you are doing some renovation in the ground floor, that should not affect on the second floor. So whatever the content we have in the second floor, that has to be there. That has to retain the same consistency. That is regarding physical data independent. It should not be a matter to the system. Whatever the changes we are making in the physical level, that should not affect on the external level. In the same way, here also we have a rule 9 with respect to the logical data independence. So here also again we have a 3, like physical level and conceptual level as well as external level. So one more thing you have to remember, we can't do any changes to the external level. So this external level depends on both conceptual level as well as the physical level. Whatever the changes we are making here, that should not affect on the external level. How we are using WhatsApp or any of the social media, though they are doing some of the updation in the background, it will not going to affect on us usage of that application. Even we won't get to know what they are doing in the background. We won't get affected by the use of that application, though they are doing some of the changes in the background. So that is what independence. So here when it comes to the logical data independence, at the time if there is change in the logical structure of the database, the user view of a data should not change. Remember, this is a best example. WhatsApp or any of the social media, if it is getting updated or if they are improving some of the feature, if they are enhancing the security and all, at the time whatever the things they are doing in the background will not affect on the usage of any of the application. That is what we are going to call that as a logical data independence. That has to be there, so that whatever the changes we are doing in the logical structure of a database, if you are changing its entity relation and if you are updating some of the constraints in the conceptual level or a logical level, then the user who are all using that database should not get affected. So that data should not change, or the view of that data should not be changed. That is regarding rule 9. We'll see the rule 10, that is integrity independence. So that means what? We should not depend on any other thing, like we have to be independent, I don't require any assistance. So that is what integrity. So we are having own consistency. So in the database also, in the relational database also, then the database has to have that capability to integrate the content whatever it has. So it should not require any other additional program or extra program or extra utilities in order to maintain the integrity of a data whatever we have in the relational Dbms. So that the database should be able to, it must be able to confer its own integrity rather than using other program. It has to maintain own integrity of a data whatever we have in the Rdbms, so that it should not use any other program to assist that. So this is also makes this Rdbms independent of front end. That means whatever the view we are getting, how we are viewing the content whatever we have in the database, so it should not have any other programming languages or any other program to use that as an utility in order to improve its integrity of a data. So that is regarding rule 10, integrity independence. We'll see about the rule 11, that is regarding distribution independence. So if I have any of the content in the server, for example, if you wanted to search something over the internet, but do you know from where you are getting, from which server you are getting, either from India only or from any other countries? Are we going to get to know from where we are getting the data? No, right? So users should not feel that. For example, if you are getting the data, one kind of data from this server and you are getting the data from another server, so users should not feel that we are getting the data from different sources. So when the user is getting the data, they should not feel any changes over the data whatever they are providing. So that is what distribution independence. So a database should work properly regardless of its distribution across the network. So if I am storing some data over the network of a database, at the time the user should not get to know how it got distributed over the internet. So that without any distribution across the network, that should not be a barrier for the user to get the content. So that this lays foundation of the distributed database. Whatever the content we have, it will going to be distributed over the network. Then that users should not feel that they are getting the data from different network. So that is regarding distribution independence. We'll see the last rule of this advantages of COTS rule, that is rule 12, non-subversion rule. For example, if you visit any of the temple, if you wanted to get a darshan of any of the god, so you should not use any shortcuts or any bypass you should not take. So even though you are a VIP and all, you have to follow the rules and constraints. That is what regarding this rule 12 says, that is non-subversion rule. So if low level access is allowed to a system, it should not be able to subvert or bypass integrity rule to change the data. Though you have that authority, you should not misuse the data whatever we have in the database. Though you have a accessibility to the physical level or a low level, so that means where the actual data is going to be stored, right? So in the physical level, the data will going to be stored. Though we have access to all these low level, which is allowed to a system, that system should not be able to subvert or bypass integrity rule in order to change the data. Though data is available, then there should not be any modification, any alteration should not be takes place. Then only we can say that is non-subversion rule. So this is regarding all the rules which has given by the EF code in order to improve the efficiency of a relational database, that is depends, or it will going to be worked in the terms of relational model. So already we know about the relational model. Now we got to know regarding the advantages of having this relational database management system, that too with the help of this EF codes, all the 13 rules. So including rule 0 we have total 13, and usually we say that we have 12 rules in the Rdbms as per the EF codes rule. These are the advantages of Rdbms. I hope you all enjoyed this chapter 1 of unit 3. So in my coming session, we'll see about this chapter 2, that is SQL, the relational database standard. So mainly in order to talk to a database, in order to access the content of a database, we are going to have the structured query language. We'll see what this SQL is all about and what is going to be included in this chapter in my coming session. Let me meet you in the next session. Until that, keep learning, keep on growing. Happy learning. Thank you.